Okay, so we're going to take a look at exploring the quadratic and graphing that quadratic. So we have an equation, and we know it's a quadratic equation because the variable to the highest degree is to the power of 2, which means this must be a quadratic function. When we say exploring, we're going to look for a couple things. We're going to look for a y-intercept. Okay, we're going to look for x-intercepts if there are any. We're going to look for an axis of symmetry. Okay, we're going to look for a max or min value. We're going to look for the range. And we could technically say domain also. We'll say domain also, but all quadratics, unless restricted, have the same domain. And then with all of that information, the next step will be we'll go and draw a graph of our quadratic, and then we'll use some graphing software to solve it. Okay, so this is in standard form. And standard form follows kind of an equation of ax squared plus bx plus c. Do you happen, like you said, 12 we know is our y-intercept here. Okay, so the c value is our y-intercept, which is great. So we can already pull that information out. We know that the y-intercept is equal to 12. Perfect. How would I write that as a coordinate?
0, 12.
Yeah, excellent. So the x value is 0 and the y value is 12. Perfect. Very simple stuff. The next thing we're going to look at is x-intercepts. And unfortunately, looking at standard form here, it doesn't give us a lot of information. We need to convert to another form. Do you happen to know what form is a lot more helpful for x-intercepts?
I can't really remember the name of it.
Okay, that's all right. What we're going to be looking for is the form that looks like this, and as I draw it, it might jog your memory a little. X minus r, x minus s.
Huh? What do you mean?
These two here. Does this form look familiar to you at all? This one here? I'll start writing it in.
I can't right now.
Yes.
Yeah. We need to convert to factor form. Okay, factor form is where we're going to get information for x-intercepts. So what we'll do is we'll add another page here. And to get the factor form, we have to go through the process of factoring. So we'll write it again. Y is equal to negative 4x squared. I think it was plus 8x plus 12. Okay. So we'll use a common form of factoring known as decomposition to solve this. In decomposition, we're looking for two numbers that multiply to the a times c value, okay, which in this case here happens to be negative 4 times 12. Do you happen to know what that is?
What it equals to?
Yeah.
48.
Yeah. Positive or negative?
Positive? I think.
Well, if we have a negative times a positive, it always ends up actually.
Negative.
Yeah,
Negative.
that's okay.
I mean,
So we're looking for two numbers that multiply to negative 48, and then those same two values have got to add to our b value, which happens to be positive 8 in this case. Okay. So when we take a look at that, actually, the two values right here, they work out great. Positive 12 times negative 4 is equal to 48. And positive 12 plus negative 4 actually equals positive 8 also. So we've already found the two values we're going to decompose our b term into. So y is equal to, we still keep the a term the same, right? A stays the same. But in this step, we're going to be splitting the 8x into positive 12x and negative 4x. And we know together they create 8x, so we don't have to worry. We haven't actually changed the equation. We've just elongated it, made it easier for us to do factoring. And the c value stays the same. We're going to factor by grouping in the next set. So I'm going to find a common factor. Do you know what the common factor out of the first two terms might be?
4.
Yeah. Positive or negative? What do you think? Pardon?
Negative.
Yeah, negative 4. And can I take a variable out?
X.
Yes, perfect. We can take negative 4x out. When we do that, that leaves us with x minus 3. And what about the second group? Can I take anything out of that?
-4.
Yeah, we can take -4 out of this one too. And that's going to leave us with positive x minus 3 again. I apologize, I have a 3 there. Give me 1 second. So our next step here is to finish the factoring part, and really you're common factoring x minus 3 and x minus 3, but for all intents and purposes, all you have to remember is because these two are the same, we can kind of do one version of it at the front, and then the other bracket is whatever was left over, which we had -4x and minus 4. Okay. Now technically this -4x minus 4, we could factor that out and we would get an a value, and we're going to do that actually. If we common factor -4 out of that second bracket, so I'm going to kind of write it in here, and I know that might look a little funny for what we're used to seeing. That'll give us x plus 1. Okay. So that -4 is by itself, and there's I think it's associative law in multiplication. I can't remember the name of the law, but it doesn't matter the order we multiply things in. So even if the -4 is the second thing, it'll always come to the same answer. So this -4 is going to come to the front. And the reason I'm going to do that is I just want to show how this relates to our factored form, that little base version we used before on the other page, where we said y was equal to a. And remember, the a is the exact same a as our standard form. We had x minus s and x minus r. So really nicely, this fits in really nicely to that model of a factored form, okay? Now, if you recall from the previous page, the goal of this was to find an x-intercept. So from here, we have this equation. How does this help us find an x-intercept? Any ideas?
I don't really remember.
Okay. An x-intercept, and I'll jump back to, actually I can do it in the top right corner here. X-intercepts all have a y value of 0, okay? So what we're going to do with this part of the equation is we're going to set y equal to 0. So we're going to say 0 is equal to that -4, x minus 3, and x plus 1. Ooh, just fit it in, kind of. -4, we can divide both sides by -4. On the left side, dividing 0 by anything changes nothing. And you can make the argument that these cancel out. They technically create a 1. So we have 0 is equal to x minus 3, x plus 1. Okay, so we've simplified a little. And we know from here, because to multiply to get a 0, one of these must be a 0. So we're going to set both of them equal to 0 to solve for what possible answers of x will give us a 0 value. Okay, when we isolate, we're left with x is equal to positive 3 or x is equal to -1. Those will be our two x-intercepts. So we'll do a quick rough sketch here. One of them's at positive 3 and one's at -1. And I know it's very common to draw a U shape like this for a parabola, but remember our a value happens to be negative. So that actually means our parabola is doing this when going through those. Okay, so we're starting to get towards our sketch of a parabola. Let's add a new page in. Let's jump back. So we've got y-intercepts, we've got x-intercepts. Next, we need to deal with the axis of symmetry. So for the axis of symmetry, we've kind of recapped our information. We have a y-intercept and we have x-intercepts. That's what we got on the last page. We need to find an axis of symmetry. And an axis of symmetry is the concept of, okay, whoops. We're going to do a rough sketch of this so that we can try to pull out some good information. We said the y-intercept is at 0, 12, so you know it's somewhere here. And our x-intercepts, okay, 3 and -1, we'll estimate, here's about a -1, here's a 3. We know the parabola goes upwards, probably does something like this and comes back down. The axis of symmetry is a line that runs directly through the middle of the parabola. In fact, it's equivalent to, do you know what value it's actually equal to, the axis of symmetry?
No.
Okay, it's equal to the x value of the vertex. Okay, so that's important to remember because that can be really helpful depending on what kind of information they give you. It's actually equal to the x value. The formula to get an axis of symmetry, if you have two x-intercepts, do you happen to know it?
The formula for
the axis of symmetry.
I don't remember.
Okay, so you had written it as r over s divided by 2. Another way you might see it written is like one x-intercept plus the other x-intercept divided by 2. Okay, both of these are the same. when they use the concept of r plus s, it's because they're referring to this factored form, and when you have your r and your s. Okay? As long as the x values are 1, you can use that r and that s. But if I hadn't factored out my negative 4 here, we would have had a really funny looking s because our x value didn't have a coefficient of 1. So it's sometimes better to think of this axis of symmetry as taking whatever the x-intercept is after you've solved both of them, adding them together and dividing by 2. And all that is what's the average between these two? And the average is the middle of two numbers, right? That's what an average of something is. So what we're going to do to find the axis of symmetry is we're going to plug in our x-intercepts. We have 3 and we have negative 1. So I'm going to say negative 1 plus 3. Okay, so we've taken this x-intercept, plugged it in here, and we've used this x-intercept and plugged it in here. So we have the two values. And then we just have to carry out the rest of the formula in this case. And it's all divided by 2 like we said. 3 plus negative 1 gives us 2. And 2 over 2 gives us 1. Okay? So what that means is this axis of symmetry has an x value of 1. And a lot of times they'll ask you to write it as an equation. If you write x equals 1 as an equation, that's the concept of a vertical line. So I'm going to jump onto Desmos really quickly. Without sketching our rest of our stuff, if I say x equals 1, that's the axis of symmetry. It's a vertical line. We'll make it a dotted line because it's kind of imaginary. We know that's going to run through the center of the parabola. We also know we had a couple other coordinates. We might as well put them in, see if they help us a little with our graphing. Okay, there's one x-intercept. Okay, x-intercept 1. The other x-intercept was negative 1 and 0. So we have another. We're getting some good information here. And finally, we had a y-intercept, like you had said, at 0 and 12. And happens to be on this page. We have to zoom out a little to get that. So that's going to be a y-intercept. Okay, so we got some good information on the page here. Let's continue our process here. We have an axis of symmetry. Let's jump back to the original page. So now we've checked off axis of symmetry, max or min. Using the information on this third page here, how can I find I'll write it in green here, a max or min value? That's a tough question. So to find a max or min, all they're asking for is the top value here, okay? The top value, which is known as also the y value of the vertex, okay? So we've already got the x value of the vertex. We know it's equivalent to the axis of symmetry. The next thing we're looking for is what's the y value of the vertex? And they sometimes refer to that as max or min. And the reason they do that, in our parabola we know is going downwards. In this case, it's called a max because this is just the highest point. If we had another parabola that opened upwards, this would be considered a minimum. The definition of max or min just depends on which way a parabola is opening. The question is, how do we find it? How do we get this info? Okay. What we're going to do is we're going to jump to the next page here. And we're going to use what's really important is the x value of our vertex. And we can actually use the original equation we started with. Okay. So if you recall, y was equal to negative 4x squared plus 8x plus 12. Okay. And we know the x value of the vertex happens to be 1. That's the axis of symmetry. So if we want to find the y value of something, we can actually go through the process of just plugging in a value of x, whatever the corresponding or the associated x value. So we're going to plug in 1 for the two x's, and then we're going to solve for y. So this is a simple substitution question. So y will become is equal to negative 4 times 1 squared plus 8 times 1 plus 12. Okay. Negative 4 times 1 squared. 1 squared is just 1, and 8 times 1 is just 1. Negative 4 times 1 is negative 4, and we're back at some very simple addition here. Oh, good. I did that in my head for a second and it didn't seem it came out. Negative 4 plus 8 is positive 4, and 4 plus 12 is 16. So the y value associated with this is 16. Okay, so our max is equal to 16, which is equal to the y value of the vertex. And since we already have the x value of the vertex, we can actually write the vertex as a coordinate from here. Okay, the x value and the y value of the vertex are 1, which we pulled from up here, and 16 is what we just solved. Okay, so let's go back and recap that a little. We now have a max or min value. We know that it's 16, so we know that this here has a topped out value of 16. What we're going to do is we're going to jump to our graphing calculator, plug in the new information we got. We had that axis of symmetry. We now know our vertex. Okay, let's put it as a coordinate. We said it was at 1 and 16, so that's a coordinate. We'll call it the vertex. Okay, so we've got that piece of information. We'll zoom down a little here. That's really good. The last thing they're asking us about, let's jump back to that original page. Oops, sorry, I'm on the wrong page here. Okay, they wanted to know the range. And we'll talk about domain actually. Maybe we'll talk about domain first. Because this is a regular parabola, okay, it's going to go left and right forever. So when you go to write domain, let's jump over a couple pages. Okay, so let's do domain over here. Your domain, depending what notation they use, is x is the element of all real numbers. And because there's no restrictions, we don't have to restrict anything. Your teacher might write negative infinity to positive infinity exclusive there. I don't know if they write it that way, but these are both acceptable ways to write that. The range, on the other hand, there is some restrictions. We would say y is the element of all real numbers such that, and then when we go and take a look at our rough sketch on the previous page here, we know that it topped out. It had a max value of 16. Okay, it'll go down forever. There's no stopping the parabola in its downward trajectory towards negative infinity, but the highest point's at positive infinity. Do you know how we could write that as an inequality? How could we write that range? Okay, so y is less than and equal to 16. Okay, so let's go back to our graphing calculator. Just like we did a line for our axis of symmetry, we can do a line y is equal to 16. And we know that that's going to be the highest value of the parabola. So let's turn this into a dotted line. Yep.
I can't really hear you.
So we've got our final line there. So when we go to make a sketch of this, and because we're not going to be, let's jump back one. There, add one more page. We're going to make our rough sketch. So I'm going to jump back to our page, and then we'll finally do it with that graphing calculator. We have our Cartesian plane. If we remember, we had an x-intercept at positive 3. So we'll make a rough estimate. It's about there. We had an x-intercept at negative 3. We had a y-intercept at 12. We knew that the axis of symmetry, do it in blue here, was at an x value of 1. So this is important to know how to actually graph this, or at least a rough sketch of it. And we knew it had a range, which means a max value of y is equal to 16. Okay, y is equal to 16. In other words, this is the coordinate of the vertex, so we can kind of write that in. Maybe I'll put it in black here. It's at 1 and 16. That's the value of the vertex. And so we have quite a bit of the information. Now all we have to do is kind of fit a rough sketch of a curve to it. Not lovely, but this is the concept of a rough sketch with all your major points of your parabola. What we'll do is we'll jump onto the graphing software. We've labeled all of our major points here, that being the vertex. We have a y-intercept. All we have to do is actually type in y is equal to negative 4x squared plus 8x plus 12. And we'll notice it's going to fit to all of our points perfectly. All right, so this is a great way of checking our work too. We've gone through it, we've labeled all our major points, and that would be the rough sketch of it. All right, so we've got all of our info. We'll jump back to the previous page, the original one here that we started at. We've now completed the range, we completed domain, and we've also done the graph of this.